You walk into a machine shop in 1965 and every third piece of iron on that floor carries the same name. Cincinnati. The milling machines, the grinders, the centerless grinders, the profilers. The name is cast into the bed of every one of them, and the man running the shop does not think twice about it, because that name has meant precision since before his grandfather was born. One of every 12 machine tools built in America during the Second World War came out of a single factory complex in Oakley, Ohio, a suburb of Cincinnati. One machine every 17 minutes. For 80 years, the Cincinnati Milling Machine Company, known simply as the Mill, was the largest and most important machine tool builder in the United States. They invented the CNC milling machine. They built the first computer-controlled industrial robot. And then they sold it all, piece by piece, name by name, until there was nothing left to sell. The roots go back to March 19, 1884, when George Miller and Fred Holtz started the Cincinnati Screw and Tap Company. Muller and Holtz were machinists, not businessmen. They made sewing machine parts, then screws, then taps. Around 1878, when the small company needed a milling machine and could not afford one, Holtz built his own. He did not just copy an existing design, he improved it. Other shops noticed, orders came in. By 1882, Cincinnati Screw and Tap found itself building milling machines alongside its original product line, and the machines were outselling the screws. In 1884, the company incorporated to raise capital for expansion. 3 years later, a 21-year-old businessman named Frederick A. Geyer walked into the shop on a routine business call and saw something that changed his life. Within 3 months, Geyer had bought a stake in the company. He was not an engineer, he was an organizer, a builder of systems. While Holtz focused on the machines, Geyer focused on the business. His first strategic decision was decisive. The company would stop making screws and taps entirely. It would build milling machines and nothing else. In early 1889, the stockholders approved the sale of the screw and tap business to a group of employees. The Cincinnati Milling Machine Company was incorporated that same year. It was a clean break. One product, one focus, one future. Geyer understood something that most of his competitors did not. A machine tool company that tries to make everything ends up excelling at nothing. A company that makes one thing better than anyone else on earth commands both the market and the margin. By 1905, Holtz had sold his shares and retired. Geyer was in full control. He wanted a facility where the mill could be entirely self-reliant, with its own foundry, its own power plant, its own engineering floor. By 1907, he had purchased land in the Cincinnati suburb of Oakley. The foundry and power plant were completed in 1908. By 1911, the new complex was fully operational. It had more than 6 acres of floor space. It was the largest milling machine factory in the world. Geyer's timing was impeccable. The automobile industry was exploding. Henry Ford's assembly lines needed machine tools by the thousands, and the mill was ready. When the First World War broke out in 1914, the initial impact on the American machine tool market was sluggish. But once the Allies realized the war would not end quickly, they turned to the United States for the tools to build the weapons. Sales climbed, the mill expanded, the workforce grew. Geyer did not just build machines, he built a culture. He practiced what he called work spreading, a strategy designed to keep his employees working year-round at the highest possible wages, even when demand fluctuated. The result was a workforce that was loyal, skilled, and deeply resistant to unionization. While other machine tool companies in Cincinnati and across the Midwest fought bitter labor wars through the 1920s, the mill's workers stayed. They trusted the company because the company had earned it. By 1926, Cincinnati Milling Machine had become the largest machine tool company in the United States. It was not a title anyone handed them. They built it one machine at a time on a factory floor that ran on the principle that precision is not a feature. It is the product. Moi la sorte. Frederick A. Geyer died in 1934. His son, Frederick Geyer, was 22 years old when he first joined the company. Some inside the mill thought he was too young to lead. They were wrong. The younger Gaia had studied mechanical engineering, served in the military during the First World War, and had already demonstrated an instinct for strategic expansion that would define the company for the next 4 decades. In 1921, during one of the sharpest economic downturns in American industrial history, the younger Gaia convinced management to branch out into grinding machines. It was a counterintuitive move during a contraction. Revenue had collapsed. The mill had 561 machines sitting unsold on the factory floor. Management salaries were cut. Employment fell from over 1,000 to 250, but Gaia saw what the short-term thinkers could not. Centerless grinding was a technology with a massive future in precision manufacturing, and the mill could own it. In September 1921, the company bought controlling interest in the Cincinnati Grinder Company. By 1922, they had moved production to Oakley and obtained the rights to key patents on centerless grinding. A subsidiary, Cincinnati Grinders Inc., was formed. The move worked. When the recovery came, the mill was positioned not just as a milling machine company, but as a full-spectrum precision machine tool builder. When the Great Depression hit, most American machine tool companies were devastated. Orders vanished, factories closed, skilled men were thrown out of work across the Midwest. The mill survived because of something most of its competitors lacked: an export business. Exports, which had represented 1/5 of all sales in 1929, grew to 1/3 of sales by 1932. While domestic competitors went dark, the mill kept its engineers employed and its foundry warm. Frederick Gaia took over as co-president in 1934 and immediately established something that would change the trajectory of the entire industry. He created a dedicated basic research department. Not an applications lab, not a testing facility. A research department whose sole purpose was to study the fundamental physics of metal cutting. How chips form. How cutting tools wear. How heat transfers between the workpiece and the tool. No other machine tool company in America was doing this. The mill was not merely building machines, it was building the science behind them. Then Gaia made a decision that would prove to be the most consequential bet of the decade. In 1938, despite a deep recession, despite contracting order books, despite every financial signal telling him to conserve cash, Gaia launched a program to double the size of the Oakley plant. He had been studying what was happening in Europe. He had seen the rearmament. He understood before most American industrialists did that war was coming and that the United States would not be able to stay out of it. He also understood that when the mobilization began, the country would need machine tools faster than anyone could build them, and the companies that had the capacity would win contracts that would define them for generations. A new foundry was designed and built. It poured its first heat in December 1940, almost exactly 1 year before Pearl Harbor. The old foundry was torn down. In its place, additional machining and assembly space was constructed. By December 7, 1941, the mill's production space had doubled from 700,000 to 1.4 million square feet. Frederick Gaia had gambled on the inevitability of war. The gamble paid. The numbers from the war years are staggering. In 1942, the Cincinnati Milling Machine Company produced 17,511 machine tools. One of every 12 machines manufactured in the United States that year carried the Cincinnati name. At peak production, the Oakley complex was turning out a new machine tool every 17 minutes. The workforce surged to a wartime peak of 8,561 employees. 27 outside foundries and 150 subcontractors fed parts into the operation. The mill machined all large United States naval gun barrels during the war. Every battleship, every cruiser, every destroyer that fired its main guns in the Pacific or the Atlantic was firing barrels that had been turned on Cincinnati iron. The company did not stop engineering during the war. That is the detail that separates the mill from most of its competitors. While other manufacturers focused exclusively on volume, Gaia directed his research team to keep working on the fundamental science of metal cutting. Out of that wartime research came two things that would shape the company's future for the next half-century. The first was Simcool, the mill's first synthetic cutting fluid. Simcool would eventually become Milacron's most recognized brand, a product line that generated revenue for decades after the last milling machine left the factory floor. The second was the post-war plan itself. In 1943, with the war still raging, Gaia began meeting regularly with 4 other key executives to map the company's future. The committee agreed on 4 goals: extend overseas manufacturing, broaden the machinery product line, enter the industrial consumables market, and develop new technologies. Every one of those goals would be pursued, every one of them would succeed. And eventually the pursuit of diversification would become the very mechanism that destroyed the machine tool business from the inside. But before the diversification came the revolution. In the early 1950s, the Massachusetts Institute of Technology was developing a concept that would change manufacturing forever: numerical control. The idea was to use coded instructions punched into tape to control the movements of a machine tool automatically. No human hand on the crank, no skilled operator reading a blueprint and making adjustments by feel. The machine would follow instructions, and the instructions would be perfect every time. In 1952, Richard Kegg, a Cincinnati milling machine engineer working in collaboration with MIT, developed the Cincinnati Hydrotel, one of the first commercially available numerically controlled milling machines. It ran on vacuum tubes and paper tape. It was enormous, expensive, and unreliable by modern standards. It was also the future of manufacturing. In 1955, the mill received a contract from the United States Air Force to build numerically controlled machines capable of producing intricate aircraft parts at high speed. By 1958, Kegg had filed a patent for a motor-controlled apparatus for positioning machine tools. The commercial birth of CNC technology was documented in a Cincinnati filing. In 1966, the mill introduced a new generation of controls for its machines using miniaturized integrated circuits, replacing the vacuum tubes and mechanical relays that had defined the first decade of numerical control. The machines were faster, more reliable, and more precise. By the late 1960s, the company had diversified into plastics machinery, industrial chemicals, grinding wheels, and process controls. The product range had expanded so far beyond milling machines that the name itself no longer fit. In May 1970, the stockholders approved a new name, Cincinnati Milacron. It was supposed to signal a modern, diversified, technology-forward industrial company. What it actually signaled, though no one could see it at the time, was the beginning of the end for the machine tool business that had built the name in the first place. Now, the 1970s were the decade when Cincinnati Milacron appeared to be operating at the peak of American industrial ambition. The company was not merely building machine tools, it was building the future of automated manufacturing. In 1973, a Cincinnati Milacron engineer named Richard Hone developed the T3, an acronym for the Tomorrow Tool. It was the first commercially available mini-computer-controlled industrial robot. A 6-axis articulated arm, hydraulically powered, constructed of cast aluminum, and controlled by a hierarchical computer system that could be programmed to perform complex sequences of motions. The T3 was installed in automotive plants across the world, including Volvo's factories in Sweden. Cincinnati Milacron had created the machine that would eventually replace the human hand on the assembly line. The robot division grew. Cincinnati Milacron built large industrial robots, primarily for the welding industry, and became one of the first companies in the world to transition from hydraulic to electric robot drives. The T3 line expanded. The T3 776 model used ball-screw electric drives instead of hydraulic cylinders. The company was pioneering tool center point concepts, improved wrist articulation, and CNC integrated robotic control. The Air Force contracted Cincinnati Milacron to adapt the T3 for drilling operations and material handling in aircraft component manufacturing under the ICAM program, the Integrated Computer-Aided Manufacturing Initiative. The company that had armed 2 world wars was now building the machines that would make the next generation of weapons without human hands touching the metal. But beneath the technological spectacle, the financial architecture was beginning to shift. Diversification had delivered growth, but it had also delivered complexity. Cincinnati Milacron was now simultaneously running a machine tool business, a plastics machinery business, a chemicals and cutting fluids division, a grinding and abrasives operation, a robotics division, and an international manufacturing network with plants in Europe. Each division had its own cost structure, its own market cycle, and its own competitive pressures. The machine tool business, the original core, was generating a shrinking share of total revenue and demanding a disproportionate share of management attention. Then came the Japanese. In the 1970s and 1980s, Japanese machine tool builders entered the American market with devastating precision. Yamazaki Mazak, Morisiki, Okuma, Fanuc. The Japanese advantage was not price alone, it was standardization. In the United States, dozens of companies built their own proprietary controllers. Cincinnati Milacron, Pratt & Whitney, Warner and Swazi each offered its own custom-built electronic brain, incompatible with anyone else's. In Japan, one company dominated the controller market, Fanuc. Japanese builders integrated Fanuc electronics into standardized, reliable, competitively priced machines that shipped from a warehouse in weeks. American builders like Cincinnati Milacron still custom-built massive, heavy iron machines with proprietary controls. Machines designed to last a century but priced accordingly and delivered on lead times that stretched into months. For most manufacturers, the Japanese machines were good enough, and good enough delivered fast and priced right. Beats magnificent on a 6-month lead time. Cincinnati Milacron recorded losses in 5 of the 10 years of the 1980s. In 1983, the company posted its first annual deficit in its history, a $9 million loss in the first half of that year alone. Plant consolidations followed. Early retirements were offered. The workforce was cut by a third. The company that had once employed over 8,500 people in wartime was bleeding talent and market share simultaneously. The Gaia family's grip on the company was loosening. The dynasty that had led the mill for over a century was approaching its final generation of leadership. In 1990, Daniel Meyer succeeded Jim Gaia as head of the company. For the first time in 103 years, the mill was not run by a Gaia. What followed was a decade of attempted reinvention that ended in dismemberment. Meyer launched Project Wolfpack in 1992, a cross-functional quality initiative designed to strip 40% of the cost and 40% of the components out of Cincinnati Milacron's machines. It was the language of consultants applied to a company built by engineers. The teams worked, some machines improved, but the fundamental problem was not cost per unit. The fundamental problem was that Cincinnati Milacron was trying to compete in a machine tool market that had been structurally transformed by Japanese standardization, and it was doing so while simultaneously running a plastics machinery empire that was growing faster, generating higher margins, and demanding less institutional drama than the machine tool business that bore the company's name. In 1980, the mill had already sold its profitable specialty chemical operations to Thiokol Corporation to concentrate on machine tools, plastics machinery, and industrial specialty products. The signal was clear even then. The company was willing to shed profitable divisions to focus, but the focus kept shifting. By 1993, excess capacity in machine tool facilities forced further consolidation. Plants closed, production lines were merged. The engineering pipeline that had once produced the Hydrotel, the T3, and the first integrated circuit CNC controls was now producing cost reduction studies. The robot division was sold to Assia Brown Boveri, ABB absorbed the T3 product line and continued to offer it under its own name. The company that had invented the first commercially available computer-controlled robot no longer made robots. The cutting fluids business, Simcool, was eventually separated. The grinding wheels went their own way. Piece by piece, the portfolio that diversification had built was being disassembled, and the proceeds were not being reinvested in machine tools. They were being used to buy plastics machinery companies. In 1996, Cincinnati Milacron acquired DME, Detroit Mold Engineering. In 1998, it acquired Uniloy, Johnson Controls blow molding business. The company was now, by revenue and strategic direction, a plastics machinery company that happened to still make machine tools. The pretense ended on August 21, 1998. Cincinnati Milacron announced it was selling its entire machine tool group to Unova Inc. for $178 million. The original business, the foundry, the floor where the Hydratel had been born, the assembly bays where 17,511 machines had been built in a single year of war. All of it sold. The surviving company dropped Cincinnati from its name entirely. It was now simply Milacron Inc. The headquarters building in Oakley had a replica of the original 1880s machine shop in its lobby, complete with belt-driven equipment. Unova purchased that building too. Milacron went looking for new offices. The company that had given Cincinnati its industrial identity could no longer afford to keep the museum of its own history. Unova renamed the machine tool operation Cincinnati Machine and merged it with its Lam Technicon subsidiary to form Cincinnati Lam. The headquarters moved to Warren, Michigan, the Oakley complex, where Frederick A. Geer had built the world's largest milling machine factory in 1911, where 8,561 workers had armed a world war, where Richard Kegg had built the first CNC milling machine, was largely emptied of machine tool production. What remained in the Cincinnati area was a fraction of what had once been there. In 2005, Unova sold Cincinnati Lam to MAG Industrial Automation Systems, an affiliate of New York-based Maxcore Inc., for $26 million in cash and notes, plus the assumption of $34 million in pension obligations. The machine tool business that Frederick Geyer had built from a screw and tap shop into the largest in the Western Hemisphere was valued at roughly $60 million. In 1998, it had been worth $178 million. 7 years later, it was worth a third of that. The math tells the story that the press releases tried to hide. Cincinnati Milacron was not an isolated case. It was a symptom of a structural collapse that destroyed the American machine tool industry between 1980 and 2000. In 1981, the United States was the largest producer of machine tools in the world, with roughly 20% of the global market and production valued at $5.1 billion. By the mid-1990s, more than two-thirds of American machine tool firms had closed. Japan, Germany, and Italy surpassed the United States in production. The country that had invented numerical control, developed the first CNC milling machine, and built the first computer-controlled robot could no longer build enough machine tools to supply its own factories. The Rand Corporation published a study on the decline. Their conclusion was blunt. While macroeconomic factors like the strong dollar and Japanese government support accounted for the initial downturn of the early 1980s, they did not explain the American industry's failure to recover between 1983 and 1992. The real question, Rand wrote, was this: why were Japanese firms the first to convert American-invented CNC technology into successful products for the mass market? And why, as the dollar weakened in the latter half of the 1980s, were American machine tool makers unable to take advantage of a surge in worldwide machine tool demand? The failure to rebound pointed to a more fundamental set of problems. The basis of competitive advantage in the industry had permanently shifted because of two trends: the rapid change in machine tool technology and the shift to global competition. American firms, including Cincinnati Milacron, lacked the capabilities to compete on the new terms. The technology was born in Cincinnati. The profits were harvested in Nagoya. The pattern repeated across every major American machine tool brand of the 20th century. Warner and Swarsea, gone. Bergmaster, gone. Kearney and Trecker absorbed. Giddings and Lewis sold to a Japanese company and later to a French group. Brown and Sharp liquidated. Cincinnati Milacron broken apart. Monarch Machine Tool of Sydney, Ohio sold for $10 million after nearly a century of building the finest lathes on earth. The companies that built the machines that built the arsenal of democracy were themselves disarmed. What replaced them was not nothing. Japanese and German machine tool builders now serve the American market with machines that are reliable, standardized, and competitively priced. Fanuc, Mazak, DMG Mori, Okuma. The factories still run, the metal still gets cut, but the engineering, the intellectual property, and the profits flow to Nagoya, to Osaka, to Stuttgart, to places that did not invent the technology but understood how to industrialize it faster and cheaper than the people who did. If you have worked in a machine shop that ran Cincinnati iron, if you have operated a Cincinnati mill or a Cincinnati grinder or a Cincinnati CNC that has been running since before you were born, drop a comment below. Tell us the model, the year, and whether it is still cutting metal. Over the past year, thousands of machinists, shop owners, and engineers have shared their experiences with the brands we have covered on this channel. That data matters. It builds a record that press releases and corporate histories never contain. The people running the machines know more about what was lost than the people who sold it. The machine tool business that once carried the Cincinnati name did not entirely disappear. It was absorbed, renamed, and passed along. In 2013, Fives Group, a French industrial engineering conglomerate based in Lille, purchased the metal cutting and composites divisions from MAG. The operation became Fives Machining Systems, headquartered in Hebron, Kentucky, about 15 miles from the original Oakley complex. Fives still manufactures and services machines under the Cincinnati brand name. They still support legacy equipment. A machinist in a government shop who needs a part for a Cincinnati mill, built in 1965, can still remarkably obtain one. The nameplate survives even if the company that created it does not. As for Milacron itself, the plastics-focused company that shed its machine tool heritage, the arc continued downward. In 2009, Milacron filed for Chapter 11 bankruptcy protection. It was sold to a group of investors and reorganized. In 2019, Hillenbrand Inc., an Indiana-based diversified industrial company best known for its Batesville casket manufacturing business, acquired Milacron in a cash and stock transaction valued at approximately $2 billion. In 2025, Bain Capital acquired a 51% stake. The company, founded in 1884 to build milling machines, is now majority owned by a private equity firm. Having passed through bankruptcy, investor groups, a casket company, and a leveraged buyout. There is no metaphor more complete than that. For anyone operating in the machine tool space today, the landscape is dominated by companies that either outlasted or replaced the American pioneers. Yamazaki Mazak, founded in Japan in 1919, now operates manufacturing plants in the United States, the United Kingdom, China, and Singapore. Mazak's North American headquarters is in Florence, Kentucky, less than 20 miles from the old Cincinnati Milacron footprint. They build 5-axis machining centers, CNC turning centers, and multitasking machines in a factory that occupies the exact market space Cincinnati Milacron once dominated. Okuma, another Japanese builder, maintains a campus in Charlotte, North Carolina. Their machines are known for building their own CNC controls in-house, the OSP system, which provides vertical integration that most competitors cannot match. DMG Mori, the merger of Germany's Deckelmaho Gildemeister and Japan's Mori Seiki, represents the global consolidation of the machine tool industry into multinational entities that would have been unimaginable in 1960. For shops that want American-made iron, the options are narrower, but they exist. Haas Automation, founded by Gene Haas in 1983 in Oxnard, California, builds CNC machining centers, turning centers, and rotary tables in a single factory in the United States. Haas does not build the heaviest or the most precise machines on the market, and they will tell you that. What they build is reliable, serviceable, competitively priced equipment that ships fast. Gene Haas understood the same lesson the Japanese taught Cincinnati Milacron. The market does not always want the best machine in the world. It wants the best machine it can afford, delivered before the job is due. Haas now ships more CNC machines per year than any single manufacturer in the Western Hemisphere. Harding, originally of Elmira, New York, still builds precision turning equipment, though the company has changed hands multiple times. For ultra-precision work, Moore Tool of Bridgeport, Connecticut continues to build jig grinders and coordinate measuring machines to tolerances that most shops will never need and could not afford. The Oakley complex still stands. Parts of it have been repurposed. The foundry that Frederick Geyer built in 1940, the one that poured its first heat a year before Pearl Harbor, was sold to private investors in 1988. As of the early 2000s, it was still operating, still pouring iron, with roughly 120 foundry workers and 60 in the fabrication shop. One of those workers wrote in an online forum about driving down Marburg and Fora streets every day, past the empty buildings that had once held 6,500 workers. He described the complex as a sad sight, but said he was glad to be part of the last vestige of manufacturing left of the once proud machine tool company that carried the Cincinnati name around the world. That phrase deserves to stay in the record. The last vestige of manufacturing left of the once proud machine tool company. That is not a eulogy, that is an indictment. Not of the workers, not of the engineers, not of Frederick Geyer or his son or Richard Kegg or Richard Hone. The indictment is of a system that allowed the most important machine tool company in the history of American manufacturing to be broken apart and sold for scrap by people who never built a machine, never stood at a mill, and never understood that when you sell the capacity to make the tools, you sell the capacity to make everything else. Cincinnati Milacron did not die because the Japanese built better machines. The Japanese built machines that were good enough, standardized enough, and cheap enough to win the middle of the market. Cincinnati Milacron died because when it faced that challenge, its leadership chose to diversify away from the problem instead of solving it. They chose plastics over iron. They chose chemicals over castings. They chose acquisitions over engineering. And when the machine tool business stopped generating the margins that the plastics business promised, they sold it. Not to someone who would rebuild it, to a holding company that would merge it, rename it, and flip it again within a decade. The Geyer family led that company for 106 years, 3 generations. They built the foundry, built the factory, built the research department, built the workforce, and armed the nation. The generation that came after them sold the machine tool division for $178 million. 7 years later, the next owner sold it for $60 million. The machines are still running in shops around the world. Cincinnati mills built in the 1960s are still cutting metal in aerospace plants, in naval shipyards, in job shops where the owner has never heard of Project Wolfpack or Unova or Maxcor or Fives Group. The iron outlasted every corporate strategy that was ever applied to it. 1 machine every 17 minutes. That is what the Oakley complex produced at the peak of the war. Today, the machines that carry the Cincinnati name are built in Hebron, Kentucky by a French company, using technology that was invented in Ohio, commercialized by a partnership with MIT, and sold to the world before the world figured out how to sell it back to us at a lower price. If you watched this far, you already know whether this channel is for you. Hit subscribe and turn on notifications for Trade Archive. And if you want to see what happens when another American machine tool company faces the same crossroads, that story is coming next. Story is coming